Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode, we're joined by Christy Dennison, machine learning engineer at OpenAI. Since joining OpenAI earlier this year, Christy's been working on OpenAI's efforts to build an AI-powered agent to play the Dota 2 video game. Our conversation begins with an overview of Dota 2 gameplay and the recent OpenAI Five benchmark, which put the OpenAI agent up against a team of professional human players. We then dig into the underlying technology used to create OpenAI Five, including their use of deep reinforcement learning and LSTM recurrent neural networks, and their liberal use of entity embeddings, plus some of the other tricks and techniques they use to train the model on 256 GPUs and 128,000 CPU cores. This was a fun interview, and I hope you enjoy it. Let's go. All right, everyone. I am on the line with Christy Dennison. Christy is a machine learning engineer at OpenAI. Christy, welcome to This Week in Machine Learning and AI.
Thank you. It's nice to be here.
Fantastic. So you've been at OpenAI for coming up on a year now. I guess you started there in January, and you've been working on Dota, the Dota 2 project there. And well, tell us about some of your experiences since joining that team.
Yeah, it's been a lot of fun. I've gotten to learn everything from interfacing with the game to also our machine learning architecture. It's super interesting. As a machine learning engineer, I've gotten to add features so the model can observe different parts of the game, and I've also gotten to learn about how we actually interface with the game. So think like if you wanted to have a bot play in Dota, they do have an API, but there's a lot of things to understand there. It's not just, we don't look at pixels. So instead of pixels, you have to use the API and find ways to represent that in a way that our model can understand it.
Were you a Dota player before joining OpenAI?
I have to admit that I don't play Dota very well, and I did not play beforehand or many games at all, but I hope by helping OpenAI 5 that it can play well for me on my behalf.
I think you and I both are in that same boat. In fact, I don't know much about the game at all, or at least I didn't until learning about it in the context of what OpenAI is doing. And I suspect that there are plenty of folks in our audience that don't know much about the game. So maybe you can tell us a little bit about Dota, starting from, why is it an interesting environment around which to experiment with AI?
Sure. So again, this is a research company. So we don't just play games all day. One of the things we really are trying to do with Dota is use it as a test bed for these RL algorithms, and that's reinforcement learning. So why Dota? We've seen a lot of strides recently with, or even actually not just recently, for decades with chess and Go. And the real question is, what do you do next, right? You want something that's closer to the real world, and that's the main application for a lot of AIs to the world. Like, how well can you affect the real world? Dota is probably one of the most complex in terms of strategy games that are popular out there right now. So there's tons of people who have already been playing it for forever, or at least as long as it's existed. And it's a complex game, not just because of, it's not just an 8x8 board, because the board does have a size, right? You have a map in Dota, and you have two sides, different teams that try to fight each other, and there are these buildings you try to destroy, and eventually there's one building, and you destroy. They call it the Ancient. If you destroy this particular building, you win the game. And it's not as simple as just taking all your characters and charging right at that other building, because there's this complex rule set that makes it so that you can't just simply win in one way. And that's something that they do a really good job at these multiplayer games, is try to keep everything balanced. So there's lots of items you can use that can give you certain advantages at different parts in the game. They also have some downsides in some cases, or they don't give you strength in another area, or they cost money, and you have to get money by killing these little minions that each side has. There's a ton of complexity behind Dota, and it would take many of your episodes to get through it all, I think. But the core of the issue is that it's a great test bed for reinforcement learning because it's so complex, because you can't understand it in as simple of an 8x8 board.
Is there any one particular factoid or metric that kind of captures for you the complexity of the game?
Well, okay, so I think the thing that really makes it interesting, I think, from a machine learning perspective, is that there's partial information, and that's all you work off of is partial information all day long. Each side has this, what they call a fog of war, and it covers your enemy's team. And unless you place certain items in certain spots, you can't see things. And if you can't see, how are you supposed to win? How are you supposed to attack the enemy? So this partial information is, I think, probably the reason that makes it the most complex. Is because if you did know where everyone was, it would be a lot easier game.
So OpenAI recently held an event that was called the OpenAI Five benchmark. What's the significance of this benchmark in OpenAI Five?
Sure. So actually I should probably maybe give you a little bit of a timeline of what we've been going through so far. So last year we had our 1v1 bot, and it beat some of the top players in the world at 1v1, but as many Dota players know, 1v1 has a restricted set of rules. It's only like kill the first tower. It's only mid lane. Basically, it's a much simpler game. And so, in order to really do Dota and really do the full complexity of the game, you have to do 5v5 with 5 players on each side. So that was last year. And this last year, we've been working really hard to bring you OpenAI 5 as it is today. And having 5 instead of 1 presents a lot more challenges than just adding 4 more bots. We had to add, as I said before, like the new game features. Going back to this last May, we had an in-house team, and they were they're pretty good, probably average players, were able to beat our OpenAI 5. And then in June, our OpenAI 5 was able to beat our in-house team. And so we're like, well, now what do we do, right? How do we figure out how good our OpenAI 5 is? We don't have a way of knowing. So we found some some very stronger test teams to test out OpenAI 5, and they were also winning. The OpenAI 5 was winning. So now we're like, well, now what do we do, right? We need to find, how do you for something that you can't measure in a scripted way, something this complex, how do you do the next thing? So that's the point of the benchmark match, was to get some, 99.95% percentile players and have them play OpenAI 5 to see how good is it? Like, where are we? What do we need to do for TI? And TI is the big competition at the end of August. It's coming up in a couple weeks. It's called the International, and Dota players from around the world get together to compete. There's this large prize pool at the end, but the thing that we really want to know is, is self-play, does it work? Or do you have this thing we called strategy collapse, where it learns only one strategy, can't recover? It's a really interesting problem, and I feel like the only way we can know if it's actually learning well is if by testing against these really strong teams.
And now this prize pool for the TI, that's like $30 million or something like that?
Something like that. I'm not too connected with the specifics, but yes, it's a pretty big prize pool.
I vaguely remember from last year's 1v1 work around Dota that there was some controversy. Do you recall what that was?
Maybe a few more details than that. I mean,
I remember there was, dig into it in a lot of detail, but I recall at around the time that OpenAI published its 1v1 results, there were, I guess, the usual questions around kind of the applicability and the generality of the results, whether the system had, some things that were, hard coded or rules that were baked in versus purely learned, whether, it had access to more or better information than a human might have, that kind of thing?
So I was not working here last year, but I can at least answer your questions about specifically, does it have better information than a human? And the answer right there is just it doesn't have any extra information. And if anything, it actually has less. We get all the information we get from the official API, which gives us information of like where the hero is and what are your abilities that are available and can you use those abilities. And there's, in fact, one of the things we've realized is that as we've been adding more features, OpenAI 5 has actually been doing really well, even when it doesn't have any vision into certain things. Like for a long time, it didn't see avoidance zones, and it actually sort of did okay. It's a lot better now that it can see them. But
didn't see what?
Oh, sorry. So there are these things called avoidance zones. One example is there's a character, they call them heroes, called Sniper, who has this ability called Shrapnel. And it's basically this area of effect spell that gives damage if you walk into it. And because OpenAI 5 didn't know where they were, they would walk in the middle and be like, I'm taking damage, now what? And just kind of stand there and take it. So in some cases, it started to sort of learn how to get out of it. But it was a lot better when it had a map around itself indicating where it was so it knew how to get out. But the thing is, even without that, it still was doing pretty well against our in-house team. So there's nothing that it had, no information it has extra. The one advantage it does have, and I think this is just because, you do have the API, you do have all the observations up front. Humans have to check other heroes manually. They have to do that switching, and pro players are very fast at it, but there's that delay of switching on the thing, whereas OpenAI 5 just can access it, as it comes in. So, but it can't react instantly. That's another thing I think some people have been talking about. So originally when we were doing this, we do this thing called frame skip. The idea is that there's 30 frames a second, and we could take an action on every frame, but it actually makes training super difficult, too long to do. So we take an action every 4 frames and then collect an observation, create an action. The problem with that is that means that your reaction time is around 80 milliseconds, which seems unfair compared to even top humans. So we actually slowed it down, although I have to admit it wasn't because necessarily we were ready to take that step of, making it even. We were just trying to speed up training because the forward pass time took so much time and doing the game time took so much time. It made a lot more sense to offset our actions. So it is now closer to 200 milliseconds reaction time, which is closer to humans. I think a lot more fair. But other than that, other than the fact that it does get all the observations at once, it's then also the other thing too is that the time to think is very different, right? Even if you see an observation and it's not till 200 milliseconds later you can respond to it. OpenAI 5 doesn't need time to think like a human does. A human, it's not just about knee-jerk reaction time. It's also about the thinking time. And, depending on how good you are, it might be involuntary or not. And that's another thing that humans don't the OpenAI 5 doesn't really, there's not a good way. I mean, we could delay them, but it's just a disadvantage humans just naturally have.
So you mentioned some things like shrapnel and some aspects of the heroes. It's kind of making me want to take a step back and talk about some nuances or details of the game that might help, again, those of us who aren't really familiar with it fully understand, or at least not fully understand, but at least get a sense of what gameplay is like. So the standard game is 5x5, or is it a game that you would have, unlimited number of people playing simultaneously?
Yeah, so the standard game is 5x5, and again, you can play 1v1, but yes, that is a standard game. Sorry, so I should probably give a little more context about the game. So there are, I think, 100 something heroes. I think it's over 110, I think. And each of these heroes has, at least 4 abilities that they have. They each have a slightly different effect than every other ability. Some of them are similar, but some of them are very different. And that's part of the reason that for OpenAI 5 right now, we have a limited hero set. It's actually not because that we don't want the OpenAI 5 to train on it. It's mainly just because there's just so many things to represent that like we have to do manual effort every single time we input a new feature to the model. And that is really where a lot of the complexity of this project exists, is just in like how do you coerce all of these API inputs into something that this the LSTM can understand. So that's part of it. The other part of it too is that I think I mentioned this a little bit before, that we have a lot of items, and each of these items, there's probably like 100 plus items, something like that. Don't quote me on that number. I have not played Dota enough to know exactly, but there are a bunch of items that each have their own effect and their own caveats and everything. There's also other actions. There's an action called scan where you can point it to the map. You can only use it every 3 minutes, and it will tell you, oh, is there an enemy in this area? There are things called wards, and they give you vision. They also can give you also call them sentry wards, and they give you vision over invisible units. So there are a number of items that can make you invisible, but so you need these other type of wards to see the invisible units. There's other items that can also help you with that. So there's like every single aspect of the game has either an item or an ability that you can change it with. And there's also a bunch of complex rules. Like there's this thing called backdoor protection, which means that your towers will start healing if you try to just rush at them at the enemy's towers, because they want to make sure that everything is even and fair, so that like you actually have to have your little minions with you in order to actually get far enough to attack the enemy's towers. It's because otherwise people would just try to surge and run towards the ancient and just kill the ancient, and that wouldn't be a very interesting game. Like the game developers, Valve, has done a very good job of keeping it balanced and interesting. And then I also mentioned the fog of war before, which covers the enemy's map, and even what you can see. You have this circle around your hero that is influenced by trees and other items other obstructions in the map that you can't see around. So like all these things come together to really make it a complex, interesting game.
And you mentioned that OpenAI currently supports a subset of the full number of heroes. How many heroes does it support? And I'm assuming that there are some limitations as a result of that in the 5x5 matches. Like I think I read somewhere that it's in like a mirror mode, like both teams are playing the same 5 heroes, or is that right?
So yes. So we used to do mirror mode, and recently we've worked on a way to make it so they can play multiple sets of heroes. And we really did that with just adding this embedding that says, okay, this is the hero you're playing right now, so that the model can know, oh, I see I have this thing. Now I use this different ability instead, or is aware of the different abilities it has to use. So yes, we have 18 heroes now. It doesn't have to be a mirror match. And as if anyone was watching the benchmark saw, we actually introduced drafting as well. And the drafting is super interesting because our OpenAI 5 picks the heroes in the order that it thinks will have the best chance of success. So, and again, it's based on the strategies it has learned.
And so what specifically is drafting?
So drafting is picking the set of heroes you want to use on your team. So from the 18 heroes, the 2 teams, so each side, one side's called Radiant, the other one's called Dire. The 2 teams go back and forth picking heroes. There's actually a setup where, usually Radiant picks first, and then Dire picks 2 heroes, and then Radiant picks 2 heroes, but those are just the specifics. The idea is that you get a chance to pick heroes that you want on your team, and that way it's not just a mirror match. Everyone has the same heroes, and it's just we're trying very hard to make this as real Dota as we can, because we want it to be like a honest evaluation of this research project. We wanted to show, like, can you actually make something superhuman for something that's more complex than games that we've already solved?
So you've mentioned a few technical topics so far. Reinforcement learning was one, embeddings were another. Can you talk a little bit about the technology that underlies the OpenAI 5?
For sure. So basically, our model is just one enormous LSTM. And the rest of the complexity is just coercing these Dota API inputs into something that the LSTM can process. We have this model architecture diagram that's kind of overwhelming, but there's just so much to observe in the game. So the different modifiers that get applied, the different abilities that you have, and also what items you have in your backpack. But when it comes down to it, we have all these inputs. We try to put them in reasonable representations. One thing that I've worked on recently, when I mentioned the avoidance zones before, is making an embedding for the avoidance zones. So the idea is that before it didn't really matter if we just say, hey, there's an avoidance zone here, just stay away, because we were doing the mirror match and there were only 2 avoidance zones. Now that we have 18 heroes, there can be more. So what we want to do is actually tell it, okay, which type of avoidance zone are you dealing with? Because you might want to step out of it, maybe you don't. Maybe you'd rather take it so that you can, because you know how much damage you'll take, so you can get to this other goal. And that's basically implemented as a map around the hero itself, and it just different cells have the embedding type in them.
So how does the map get translated into an embedding?
Oh, so it's literally like an 8x8 grid around the hero, and if we see, the avoidance zone covers this cell, just by distance detection from the center of the avoidance zone, we say, okay, this one is this type, and then we put it through the embedding and then feed it into the LSTM.
So folks that are listening that have been following along with the Fast AI course with us, we've been doing a study group around this Fast AI practical deep learning course, and embeddings has figured pretty prominently in that course as a way for us to capture a pretty broad variety of characteristics about different entities into deep learning models. So it's interesting to hear that they play so prominently in the Dota model as well.
Oh, for sure. And we use them for, if I could show you the diagram, but they are across the board here, because there's just so many things that have different types. There are, several hundred modifiers, and modifiers are ways of knowing if there's a spell cast on you or something like that, or if there's an ability that you're using. There's so many different things that have different types, so it's absolutely essential that so many things go through embeddings.
And so the embeddings, are you training the embeddings separately, or are you training all of this end to end?
It's all end to end.
And so you've got this gigantic LSTM. I think I read it was 1,024 units. Is that still accurate?
I think, that's been changing so much. I think we might have, it's actually 2,048 now. Because I think the 1024 was for our 1v1, and so we figured we should probably raise it for 5 heroes. And
are the steps in the units in the LSTM, are those time steps in the game, like frames, or are they some other unit?
For each time step, we have all of these different inputs. I've not worked on that specific section, but the time step we look at right now, I actually do not remember I think it's 16. It changes based on if we're doing local training or not, but I believe when we're doing training for an experiment, we're looking at 16 time steps at a time, and that's with the frame skip.
Okay.
So that would be 2 seconds, something like that.
You mentioned that you do a lot of different types of transformations that a big part of the challenge here is figuring out how to feed information into these LSTMs. It sounds like a big part of that is using embeddings, but are there some other things that you're doing in terms of representations for making all of this tractable?
Sure. So, I mean, besides embeddings, another thing that I've worked on recently is adding a mini map. So this is a part of the game that all the humans get to see, and OpenAI 5 never got to see. And it's just this high level view of like what vision you have, where the enemy units are, things like that. And the way we handled this, because we couldn't talk to the client code, is just trying to recreate the vision. So what we have is this input. We start out with this large grid. It's 260 by 260, and we draw all of where all the vision is on the map. So you get vision from towers, from heroes, and we overlay it. And so you've got this one nice vision channel. And then we add other channels, like, oh, here's where your heroes are, and another channel for where your wards are, and another channel, for all these things. A channel for, your creeps, the minions. So we add all these up, and then we actually put that through a ConvNet for the model to understand. And so far, it has been helping with ward placement, or so we think. It's hard. Ward placement is really hard to figure out because it's something that requires a lot of strategy, and not every single ward placement makes sense for every single part of the game.
What's a ward?
So the ward is something that gives you vision. Remember, because like the entire map's covered with this war. So so what you really want to, you can't evaluate. That's the other thing that makes this really complex, is that it's hard to evaluate good behavior. A lot of this behavior we can't see till really late in the game. So, again, for the ward placement, by late in the game, I don't mean the actual game. I mean late in training. And that's something we actually don't have a lot of, without comparing two agents that are similar skill levels. It's hard to tell, are you doing this well or not? And that's part of the reason we had the show match. But we have a scripted bot we made a year ago that, does okay. I think it beats me pretty consistently. But an average player would probably be able to beat it, because you can't script these complex behaviors that well. That's the thing we ran into first, is you can't create a set of the OpenAI 5 with just scripting. You have to have something else that's learning, that can figure out these complex strategies, because you can't code them up.
You mentioned, I guess what I think of as kind of a reward attribution type of a problem, meaning things happen in the game, and if you're just measuring the agent's progress on wins and loses, you don't really know until late in training. But I read something about how there's been some experimentation with that binary type of reward relative to more incremental types of awards. So looking at, kills and hits and things like that. Specifically, some experiments that were done comparing sparse rewards versus dense rewards.
So yeah, this is something actually that, interestingly enough, we have been doing some research on. So when we first started doing 1v1 bot, one of the things that we really wanted it to learn was creep blocking. And it's the idea that, just statistically, if your creeps end up in the middle of the map, slightly over the middle of the map, into the enemy's territory, the enemy can start taking those creeps and killing them faster. And you tend to statistically do worse. And so a lot of people tend to creep block at the beginning of a game, where they'll stand in front of their creeps and prevent them from running to the beginning of the map. And so if your opponent is not doing that, they will end up getting their creeps on your side. Your tower will try to take them out, and you generally do better that way. They couldn't, even with all the training they did, they never saw this happen for 1v1, so they had to do this shaped reward, basically, give a reward for blocking the creeps. However, when we did let it run longer, and this was, I think, earlier this year, we actually did start seeing a little bit of that behavior. So I think when it comes to sparse or dense reward, and this is just off of some of the experiments we've seen, you can sometimes see these these good behaviors that you could get out of a dense reward. but you have to give it a lot more training time. And so it's really as a trade-off of like how much training time do you need to give it. So we do give rewards for kills and things like that, but in taking towers, you get the gold reward. And you have to do that, otherwise I think it would just take too long to see any good results. It's sort of interesting effect of this, and we saw actually in the recent benchmark is the third game. And one of the things that happened is the crowd picked the draft, and so the draft was terrible for OpenAI 5, absolutely terrible. It predicted a 2.9% chance of winning, which is pretty abysmal. So it did lose, but the interesting thing is that we started to see these behaviors where the heroes would sacrifice themselves to take a tower, which is kind of strange. Like, why are you changing your behavior so much to do something like taking out of tower? And what we realized is that we've kept the rewards, symmetric. If you win, you get 1. If you lose, you get -1. But as standard RL practice, you generally have this gamma term that is your horizon, right? And so you generally discount the rewards, positive and negative. And so if you think you're going to win, it makes sense. You're going to try to drag that game out as long as you can to make sure that penalty is as low as possible. So I know, right? It's kind of hilarious. And this is what we saw. So now we're like, well, now some of that behavior makes sense. You sacrifice yourself because if the tower is down, then there's more time in the game because now the enemy team's going to have to work harder to keep it balanced. Even if you eventually lose, you're like, okay, well now I, got a much smaller penalty. But it's hard because you don't want the two teams collaborating, right? Right, in general, right. Asymmetric awards are not good. And we did try a little experiment so far trying to see how that works, but it's tricky. It's really tricky to try to get these things right.
And you end up with a lot of possibilities for unintended consequences and things that unfurl in unexpected ways, I would think.
Oh yeah. I mean, it's just so many tweaking. I think that's the reason we're doing the research, right, is to figure all these things out. But even like a few weeks ago, we were talking about how just changing our learning rate, we're just like, hey, why don't we experiment with a lower learning rate? And guess what? That helps. Like, there's so many, it's too bad we can't have the OpenAI 5 figure out how to do all these things, right?
You've talked quite a bit about reinforcement learning, and some of the papers that I've seen referred to in the context of the OpenAI 5 and the previous versions were PPO and Rainbow and Observe and Look Further. Can you talk a little bit about the roles that each of these plays and how they're used in the kind of the training regime? Sure.
So we basically use a pretty scaled out version of PPO. We have our training setup it's training framework we call Rapid, that allows us to scale out a lot of, all of this training. Because as you know, with reinforcement learning, you need lots and lots of samples. So we have, I think in our recent blog post, we were talking about how we have 180 years of training every single day. And that's because we're running all of these games in parallel. And again, it's basically scaled up PPO. One of our recent experiment our recent large experiment that we used for the benchmark had 80,000 CPUs and 1,000 GPUs. And about half of those were optimizers. The other half were just doing rollouts. And we also have infrastructure for doing evaluations, so that we have this giant tensor board that tells us how everything's going. We look at sample reuse. We look at the mean reward. We look at all these different aspects of the training to figure out is this going well for us? Is it not? What can we tweak? What can we not tweak? It's a really great framework for running experiments, and we use it in other teams at OpenAI as well.
So there are two different types of nodes. One was for updates and the other was for something else. What were those two?
So part of what Rapid does is it handles a lot of the scaling out. We have a whole different clusters of machines that are used for the whole training process. And one of those are the optimizers. The optimizers handle all the backprop, taking the new parameters, spreading them out to the machines again, combining the parameters. And then the other half of the machines, for the most part, are the rollouts. And we have both GPU rollouts and non-GPU rollouts, because so it's basically, if you want as you're running the game, doing your forward passes, do you want it to be run on GPU? And recently we've made that infrastructure change so that it can run on GPU. And that does help us not as much speed up training, except when we've made the model a sufficient size, then it actually is faster to run it on a GPU.
And so what is a rollout specifically?
Oh, yeah. So rollout is just playing the game, right? So it's creating samples. So we have all these machines that are creating samples, playing the game, seeing here's an observation, here's the next observation, here's your action. And then all that gets packaged up and sent to the optimizers. And then we also have a bunch of machines that do evaluations. And so what they will do is, take a snapshot of the parameters and play again against our scripted bot. And then it will report the results. Of course, that's usually only useful for the very early part of training, because, again, the scripted bot can only do so much. So it's used for new experiments, but later on we have this other piece of infrastructure we call Scoreboard, where we can snapshot parameters, play it against other snapshots, and see how they compare. And that's really how we decide, coming up to a match, what is really the best of something, because otherwise you just can't tell. And at a certain point, even with all of these snapshots, we still need humans to evaluate, because there probably, as I mentioned this early before very quickly, the problem of strategy collapse is what we've been calling it, where your OpenAI 5 might be learning only a small handful of strategies and maybe not learning everything, just hasn't practiced that.
Say you have 5 different models that, come from 5 different training iterations. Could each of those play a different hero on the same, in the same game, on the same team? You
could do that. It would require extra infrastructure work. Right now, we're just sort of doing all of them in parallel with the same brain. So they all do have the same brain. We're just giving them different inputs and running all of the forward passes in parallel.
You've got these brains that you train for the heroes. They use these embeddings so that they can, the brain can control any of the heroes that OpenAI 5 supports at a given time. And then it sounds like you play different versions, one against the other, to determine which ones are best. How long do you play them against? Is it a certain number of games or a certain number of quote unquote years, days of play, to assess, a given model versus against another model?
So the way our scoreboard is set up right now is that it will try to find the most recent agent that's been uploaded and play it against other ones that have the same environment. Environment just basically means we can set up an environment so it's just like sniper versus sniper, in which we've done a lot of tests for that. And then more recently, we've had the ones where we have our 18 hero set. So Scoreboard looks around and says, okay, who are the new agents, and tries to, bias it so they get the most new games. But then other agents also get games. I think it tops out around, I don't know the exact numbers, but something around maybe 10,000 games. It'll start to ignore you entirely, because it's we've established what your skill level is. But other ones, it's just basically on a need basis, depending on the because so many people are constantly uploading things for their individual experiment, because once you get past the scripted bot, you can't really tell very well.
Okay, so it's kind of like a CI/CD system. You create this model, you experiment with it, and then you upload it into this testing infrastructure that basically just pits it against other models and determine how it fares against them.
Mm-hmm.
Maybe jumping ahead to the actual benchmark match. Can you give us the highlights of the benchmark match? First of all, what were the results?
Yeah, so the results of the benchmark match were the first 2 games. OpenAI 5 won against the humans. And there's one thing you have to understand. These humans have played for 10,000 hours against this game. These people are very good at what they do. The players we had at the game were some were previous pros, but are casters, but they understand the game so well that they're able to talk to other people about it. And I think that's really a great demonstration of how well they know it. So they're excellent, 99.95% percentile players. And they lost the first 2 games. And the only reason well, not the only reason, but I think the biggest reason they won the last game was because of this adversarial drafting that our audience and Twitch chat were able to assist with. So that's the big thing. And I think it's not as much. There's a couple things with the drafting results. So the first ones, for the first few minutes of the first 2 games, it was tracking pretty even, but that's how most games go. You don't really know if you're winning or not, even if things are even. Like, OpenAI 5 got a kill, they got a kill, it was sort of even, but then things change because then OpenAI 5 starts pushing, and they push their lanes, and pushing the lanes basically means going to the other side of the base and really trying to take the other side. So... And even humans had to sacrifice a lot to get some of their first towers. And so even though they were getting the towers, it didn't mean that they were really ahead because they had to sacrifice so much. And then after that, it just kind of went uphill for OpenAI 5.
The fact that the game opens up late in the game, does it have to do with that OpenAI has kind of figured out the right time to start pushing? Or do you see like the culmination of some longer term strategy that OpenAI had been playing all along that, either the humans were oblivious to or couldn't effectively counter or something like that?
So I think it's both. And it's again, because I think this is actually a complex problem because, a lot of professional games even will be pretty even at the beginning, or even just amateur games. So having advantage at the very beginning does not mean you'll have an advantage later in the game, but it can. It's sort of a hard answer. I think the other thing, how I was talking earlier about the asymmetric awards, we did start doing an experiment where we said, okay, fine, no penalties, right? And the games do finish faster because they're trying to maximize that reward. So it could be, I think it's a little of both. It's, most games do start out even, but then also I think, OpenAI 5 is motivated to, make it a little longer than normal.
Wear the humans down.
Yeah, there you go. So it's all of these things. This is why I think after TI certainly we'll be doing a lot more like ablation studies, things like that, to figure out exactly how much of a contribution each of these things make. Because right now we're just sort of rushing to the end, trying to make the best OpenAI 5 we can. But we really want to understand more in depth how each of these little knobs affects the performance.
Are there any other observations that are noteworthy coming out of the benchmark? I mean, certainly there are. What were some of the main things that, either the OpenAI team or the audience or the commentators observed about the way OpenAI had learned to play relative to humans?
Yeah, so I don't know too much about specific strategies. I feel like you have to have a certain level of Dota understanding to really understand how these things work. One of the things the commentators did say is that they tend to go very much for pushing lanes, which means that they'll just kind of go straight for it. There are numerous valid strategies in Dota because it is a very complex game. They tend to take on these more, hard fought strategies, like where you just kind of go for it in some cases, and they have the confidence to make it through most of the time. Not always, but they also support each other. That's the other thing that we saw in the last, even our Turtle games, is that we have this hyperparameter called team spirit. And what we do is, if we turn it up, it basically is like a shared reward. So if the higher it is, the more reward you get for some of your teammates' kills rather than just one of your kills. And interesting thing, so it's down at 0, they play terribly, and if it's a 1, they play terribly. So there is a mid-ground where you have to be a little bit selfish, but also care about your teammates enough to go help them when they're dying. But it is interesting. They seem to play more collaboratively than humans at times, seem to care about each other a little more. So I think that is part of the reason that they have done so well.
Now, you mentioned, or I saw in a video somewhere. One of the commentators was talking about some strategy that he observed the bots playing. I think it was something like keeping the center of the board clear or something to that effect that, it took him 8 years to figure out or something.
Yeah. So at our first, we published a video and a blog post a little while back. And one of the interesting things about the Dota board is that it's not symmetrical. So, it's sort of symmetrical, but there are some different parts. And so what Blitz, who was commentating those games, was saying is that there are the bottom towers on the Radiant side are surrounded by forests. So it's actually really hard to defend those towers. And so his advice is if you're playing Radiant, don't even bother. Just let them take those towers because you have a much better chance of taking out the enemy at your mid towers and your top towers if you're Radiant. So he's just said that it's very hard to defend the ones in the weeds. So there's a lot of strategies there, and I think the questions you're asking me is what are these high level strategies? It's part of the reason we had these very well practiced humans come look at these things, because these are things that a lot of us just as machine learning engineers and researchers, we can't spot ourselves. Because it requires so many hours of gameplay that we haven't done yet.
Mm-hmm. So maybe to wrap up, can you talk a little bit about how this fits into the broader landscape of projects at OpenAI? You mentioned that the next big challenge is TI. Is this OpenAI 5 allowed to compete in TI for the 30-40 million, or is it just a milestone, or are you planning some additional benchmarking kind of there?
Yeah, so we're just doing this for, again, OpenAI is a research organization, so we're not planning on being part of the human pool, as we're not entering a human. But I think the main thing for us is really just to see how well we can get OpenAI 5 to work. That's our main and only goal, is really to see, can we get superhuman performance from reinforcement learning and self-play?
Well, Christy, thanks so much for taking the time to explain all this complicated stuff to us and help us understand what OpenAI is doing and why you're also excited about the OpenAI 5 playing Dota.
Great. Well, thank you for having me. It's been a pleasure.
All right, everyone, that's our show for today. For more information on Christy or any of the topics covered in this episode, head over to twimlai.com/talk/176. If you're a fan of the podcast, we'd like to encourage you to head to your Apple or Google podcast app and leave us a 5-star rating and review. Your reviews help inspire us to create more and better content, and they help new listeners find and enjoy the show. As always, thanks so much for listening, and catch you next time.